Let's take some minutes to talk about VPCs and subnets in AWS. This is really part of the AWS Fundamentals set of skills that I highly recommend everyone has a good understanding of whenever working with the cloud and more specifically with AWS. Quick introduction here just for us to know what a VPC is and also what a subnet is. So VPC is really a logically isolated virtual network within AWS to deploy and launch your resources. AWS is structured in regions. We have multiple regions across the globe, in Europe, in America, in Asia, lots of regions, and each region has also multiple availability zones. This number of availability zones, it changes based on the region. Some regions are larger, they have up to 6 availability zones. Others are smaller, they have, for example, 3 availability zones. And whenever we create a VPC in AWS is restricted to a region, but it spans more than one availability zone. The VPC is really the foundation for networking, resource placement, connectivity, and security within AWS, and it is basically isolated from other networks within AWS. If you deploy a resource in your VPC and I deploy a resource in my VPC, we cannot talk to each other except if we establish a connection explicitly. This gives a very good layer of isolation, which means that if our resources are running on a part of our VPC that is not exposed to the public internet, then these resources are not reachable from outside of our VPC. We can also have more than one VPC in a certain region, and we can have as many VPCs as we want. I mean, there are probably some quotas and limits here from AWS side, but we can have more than one for sure. And we can use also these VPCs to isolate different resources that should be grouped and isolated from one another. So think about it as a logic partition from a networking perspective. It will give you a set of IPs. We're going to talk about this in a bit. So the IP CIDR block can be between a /16 that gives you roughly 65,000 addresses and a /28 that gives you just 16 addresses. And we will not get all these addresses. We'll talk about it again. We will also explain what this / means, because this is very important to understand how the partition of IP addresses really works and how we can then design certain VPC and subnet so that we have the correct setup from AWS perspective. The VPC, as I already said, is restricted to a single region, and AWS accounts come with the default VPC per region. That means it's not just one default VPC that comes in your account, it is one default VPC per region. Each default VPC already comes with a one default /20 subnet per availability zone, an attached internet gateway, a route table entry sending all traffic to the internet gateway, and it is recommended not to use the default VPC, but rather to create and configure non-default VPCs. That is really just custom VPCs that you define and you configure with better security and networking configurations. That brings me to the topic of subnets, and while a VPC spawns multiple availability zones, subnets are restricted to a single availability zone. They are basically partitions of our VPC that we can then assign specific CIDR blocks, specific IP ranges. So it logically splits the VPC IP range into non-overlapping subranges. This is very important. You cannot define subnets with overlapping IP ranges. If you do that, that's going to be a misconfiguration. It's not going to be allowed by AWS. And that's basically, if you think of the VPC as a cake and the subnet as a slice, it's really, there is no way of creating overlapping slices of a cake, right? Doesn't make sense. So you can think of all the amount of, or all the IP addresses that we have within a VPC as being the whole cake, and then we split it across subnets. The subnet is limited to a single availability zone, but we can of course have multiple subnets, each one placed in a different availability zone. And the IP ranges as well CIDR block between /16 and /28, and AWS reserves the 4 first and the last IP addresses in the range for its own usage. That means that if you have a /28, for example, you will have 11 addresses available instead of 16. In terms of internet access, public subnets are reachable from the internet. Private subnets are not reachable from the internet. They don't have an attachment to the internet gateway. And it's possible to set up only outgoing traffic via a NAT gateway for patching and updates. So all this we'll talk maybe in later videos. I'm not going to go into the details here of internet gateway, NAT gateway, route tables, and so on. This deserves a discussion of its own. But imagine that you have, for example, a database that you don't want to expose to the public internet. You want it to be accessible only from your servers, from the backends running in a VM, for example, and you can place this subnet in a place this database in a private subnet, and then make sure that it is not reachable from the internet, but it can still go outside. It can still have an outgoing traffic to the internet so that patching and updates in the database software can be done. Let's then move on to CIDR blocks. We talked a lot about /this, /that, and that's now we're going to understand what composes a CIDR block, or at least the high level of it. And basically a CIDR block is a collection of IP addresses that share a network prefix and number of bits. Okay, so CIDR blocks consist of an IP address and a suffix indicating how many bits from this IP address are fixed. The IPv4 address contains 32 bits. We're going to use IPv4 here because it's just shorter, but the principles are the same for IPv6, even though it uses 128 bits. So this suffix of this / whatever number you have here informs that the first number of bits of this address are fixed. The last 32 bits minus the number, right? So if you have /16, this would be like the last 16 numbers, or the last 16 bits are variable and can be used to identify resources within the network, right? So CIDR blocks follow similar logic when applied to IPv6. And here is one example of a 10.0.0.0 IP with a /16 suffix. That means the first 16 bits here are fixed, and this is how we encode it in binary, and the last 16 bits are available. Now, if we have 16 bits available, they can be either 0 or 1. That gives us 2 to the power of 16. That gives us 65,536 addresses. Now, as we mentioned, we could split this group here into smaller non-overlapping address groups, and we can do that, for example, by using a higher number. That means we are fixing more bits at the beginning here. So this would be an example of a 10.0.1.0 /24, where we fix the first 24 bits and we leave only the last 8 bits. That gives us 2 to the power of 8, 256 addresses that we can use within this CIDR block. And then here is another example. This would be a non-overlapping CIDR block, and that's because we are changing the bits in the fixed part. If we were to use 22 here, for example, and 22 here, for example, then we would have fixed up to here, and this would be variable, and then this means that this would be an overlapping IP or an overlapping CIDR block. Right, so now that we know how this works, and this is really the high level overview here, just for us to understand how to translate this /16 into the bits and into the addresses that we have available, let's have a look at the AWS default VPC and the subnet addresses. This image here comes from AWS. The source is here, always good to attribute, right? So this is what's provided for us. It's provided a VPC with an IP address or a CIDR block of 172.31.0.0 /16. That means we fix this first 16 bits, and the rest we can use as we want. We then have one subnet, this 172.31.0.0 /20, and now here we are fixing 20 bits. We have then the .16.0, then we changed this bit here from 0 to 1, and we also have the 32.0, and then we are changing the 5th bit here, or rather the 6th one. Right, so this is how the default VPC and the default subnets are shipped by AWS. And by using a suffix of /20, we have 2 to the power of 12, right? These are the 12 bits that we can vary, minus 5, because these are the 5 IP addresses that AWS keeps for itself. So we have 2 to the power of 12 minus 5, that's 4091 IP addresses within the subnet. We can use these IP addresses to deploy our resources, and they will be most likely allocated and assigned automatically by AWS. And so also when we use a /20 for the subnets, that means we have 2 to the power of 4 available non-overlapping CIDR blocks, right? If we look here, considering that we can vary only the 16 final bits here, and we are using /20, that means that we are allowing ourselves to vary these 4 bits as the quote-unquote subnet identifiers, or like basically these are the 4 bits that we can vary to make sure that there are non-overlapping ranges. That means we have 2 to the power of 4 bits that we give ourselves here, and this gives us 16 subnets within the default VPC per region. Whether this is good or this is bad, there's really no answer set in stone, or it depends on how many IP addresses you expect to use within each subnet, as well as how many subnets you expect to use within a VPC. So this is just a number that you can fine tune to trade off between the number of IP addresses that you have available within a subnet and the number of subnets you have available within a VPC. Right, so that's it for an introduction of VPCs and subnets. Hopefully now it's a little bit more understandable what's happening behind the scenes when we are deploying some resources, where we are deploying them, right? It's basically inside of a VPC that covers a single region. We can have multiple VPCs also within the region, but the VPC is always bound to a region. If we change the region, that means we also change the VPC. And then within the VPC here, we start defining subnets within our availability zones. And then within these subnets, it's where we actually deploy our resources. Whenever we deploy a VM, for example, an EC2 instance, a compute instance within our subnet, then this gets assigned one of these private IPs from this IP pool here that is assigned to the subnet. Great, so this gives us the foundation to understand where we are deploying our resources. That's it for today. And of course, there is much more coming. So if you don't want to miss, make sure to subscribe to the channel, and I'll see you in the next video. Have a good one. Bye-bye.